Hey guys, Mr. Reese here, Algebra 2, Section 4.6 of our book. Today we're talking about imaginary and complex numbers, something brand new for us. As we kind of go through and talk about what this is, imaginary number is the square root of a -1. This is something that we haven't been able to do before in the past. When we come up with square root of -1, we say, hey, we can't do it. We may say no solution or something like that. Well, now we've made something up. Literally, it's imaginary. We've made it up and we said, hey, I equals the square root of -1. That helps us do problems. Instead of stopping at negative solution, or sorry, no solution, we can keep going. What we really meant in the past is we didn't really mean no solution, by the way. We meant no real solution. The opposite of real is imaginary. That's what we're talking about today. Things actually have imaginary solutions. So that's what we'll kind of focus on. When you deal with imaginary numbers, what you really talk about is a complex number. A complex number has a real part and it has an imaginary part. Together, the real part and the imaginary part make a complex number. In your graphing calculator, it's nice to switch the mode. If you go to mode and switch the mode to A plus BI mode, it will help you be able to do some of these different things in your calculator. So what we're going to do with imaginary numbers is we're going to solve things. Solving with imaginary numbers could be any of these methods. We've learned these three methods in the past. We're going to put these methods to use here. And so we're going to talk about when these occur. So let's say you're solving something like this, x squared equals the square root of -5. In the past, as soon as you do this, you say, there's no answer. There's no solution. You just stop. Well, we're going to move on. We're going to say, actually, we know that we can break radicals down. And now that we have this little tool, this imaginary number, square root of -1, we know that's I. We can say, actually it's 5i. So we can continue. Square root of -25 is 5i. We have plus or minus 5i is our answer here. So that we can use that to actually be able to solve things. Another one here, when you're dealing with a different kind of problem, this one we'll do by square roots. Subtract 35, divide by 2, just like normal. In the past, we get right here and we say, want, no solution, can't do it, we are stuck. But again, well, that's not the case anymore. Well, at this point, we can say that we know how to do this. We can say, actually, we have this 2i square root of 2, and we can continue the problem. Drop the bars, add plus or minus, subtract the 5 over, and now we actually have an answer. So instead of having to stop here, we do know it has no real solution, but we'll actually say this. We can actually solve it now. Another thing that we can do here with imaginary numbers or complex numbers is plot them. So this plane to the right shows how we plot them. So you have a real number line and you have an imaginary number line, and together this makes what's called the complex number plane. So if you're going to plot something, let's say you had 4 plus 2i. Well, the real part, which is 4, you can go over 4, and the imaginary part 2, you go up 2 and you plot this point. No big deal. That point right there is over 4 and up 2. These work for a number of different points. -3, -1, so to the left 3, down 1, sweet, you have the blue point. Same thing if you had this point, just 5i. So this just has an imaginary part, so it'll just be on the imaginary number line here. So plotting points in a complex number plane is just like plotting regular points. As you keep going, one of the reasons that we do this with complex numbers is that we can find the absolute value. Well, as you probably know, absolute value is really the distance from 0. So when we talk about, hey, how do you find the absolute value of 3 minus 4i? What we're really talking about is how do you find the distance from 0? Well, let's see. 3 minus 4i, let's put that point on there to the right 3 and down 4. That's kind of our first step. Plot the point, put it on the graph. And then we're talking about the distance it is from 0. Well, in this case, 0 is the origin, 0, 0. That's really what 0 is. Well, we could use the distance formula, but everyone knows that the distance formula kind of sucks. So let's do something else. The other thing that we could do is we can make a triangle. The nice thing about a triangle, if this is a right triangle, hey, I know this leg is 3 and that leg is 4. Well, this is really the most famous formula in all of geometry. This is the quadratic or the Pythagorean theorem, a squared plus b squared equals c squared. So we're going to use that. Plug our numbers in. Maybe you already know your triples already and you know that c is going to be 5. So that distance there is really 5. All right. So then we can kind of move on and say, hey, the absolute value of this number here is 5. Beautiful. Here we go. A few other things to do with imaginary numbers. Anything to the 0 power is 1. I to the 1, we'll just call that I squared, this is a really important one. This pops up a lot. What is I squared? Well, it's really -1. There's a couple reasons why that is, but I'll just leave it at that for now. I squared is -1. I cubed is -I. Well, if you notice here, there ends up being a pattern. If you keep going back and you say, hey, what's I to the 4th? I to the 4th power would be I squared squared. -1 times -1 is +1. This would be I to the 4th. It would also be 1. If you look at what I to the 5th would be, I to the 5th would be I to the 6th, oops, I to the 6th there, and then I to the 7th. What happens is there's only so many answers this could be. There's only these 4 answers. And so it kind of cycles around. And one way to kind of do this is say, hey, let's look on the number plane. Right there, that point would be I to the 0. That's our starting point. Okay, that's where we begin. When we deal with like I to the 1st power, well, that's up here. And we go to I to the 2nd power. That's right there. I to the 3rd power is down here, and I to the 4th power is up there. It's kind of like a cycle, and you come back around. So any power of 4 is really going to be back at our starting point. So if we do some problems, say, hey, let's find I to the 12th. Well, since 12 divides by 4, that's going to be back at our starting point, and that's going to be 1. I to the 12th is 1, because 12 divides by 4. Sweet. All right, let's try another one. Maybe 127. Well, one thing you could do is you could just start counting. Here's 0. 1, 2, 3, 4. We're back. 5, 6, 7, 8. We're back. 9, 10, 11, 12. That's 12. That's what I could keep counting and counting and counting all the way to 127. Now that's kind of a waste. What's better is if I say, hey, is there anything that divides by 4 here? Does 127 divide by 4? Well, no, it doesn't, but we're talking 31.75. What happens is I would go around 31 times around this circle, and I'd be left with this 0.75, which tells me 1, 2, 3. That's sort of like 75% of the way around the circle, or if you want to do it as a remainder, it'd be like 3/4. It'd be 3 more spots around the circle. And so my answer here would really be -I. So to be able to deal with these powers, all you have to do is be able to divide by 4. Some people do this, 120 divides by 4, so I just go 7 more spots. 1, 2, 3, 4, 5, 6, 7. Yep, 7 more spots to get back there to -I. It's a nice skill to be able to deal with. As we keep going, adding complex numbers is super easy. Just combine like terms. 4 and 3 is 7, 6 minus 2 is 4. Problem's over. We completed it. Subtracting is really similar. Make sure that you distribute the negative sign. So we'll go ahead and distribute there and then combine like terms. Adding and subtracting, super easy. As we keep going, multiplying. Multiplying is foiling. So we'll kind of show this and multiply all these terms together. The key here is to be after we combine like terms is to kind of be careful about this I squared. So this I squared term, remember that I squared is really -1. Once you know that, we replace that with -1. So that's plus 12 and then add it up. So there's our answer at the end. By the way, you can also do this in the calculator. The calculator will be able to multiply these binomials together if you type it in. Dividing. There's 2 different kinds of dividing with monomials and with binomials. And we'll kind of do each of these sort of separately, but it's a lot like radicals. And so when you rationalize the denominator, which means get the I out of there, what we're going to do is multiply by I. You may ask, well, why do we do that? Well, when we have I times I, we have I squared. The thing about I squared is I squared is -1. That's a nice thing to kind of remember, that I squared is -1. So 3 times I squared, 3 times -1 is -3. Well, the beauty about that is that there's no more I in the denominator. That's the key. We don't want a square root, which really what I is. Remember, just square root of -1. We don't really want a square root in the denominator. So that's the idea. There we go. When we divide binomials, it's a lot like when we dealt with radicals with binomials. So we have to multiply, this is called the conjugate. We'll multiply by the conjugate, and we'll kind of show why. Distribute, the same thing on the bottom, we FOIL, and we get all these terms off to the right. A little review of that's called the conjugate. Well, what happens here is when you do multiply by the conjugate, that and that, those two things cancel each other out, which is beautiful. So that means its i's go away. The other thing that's beautiful is that I squared, remember what I squared is? I squared is -1. So that's nice because now we really have 4 minus 9 times minus 1. So that's really 4 plus 9 because I squared is -1. And in which case, we can kind of continue on and finish off the problem. Remember, the key to this problem is we don't want any I or radical in the denominator. That's why it's called rationalize the denominator here. All right, good deal. That's really the end of it. The biggest thing to be able to do on this is solve quadratics. So that's kind of our main goal using imaginary numbers. But there's a lot of other side things: adding, subtract, multiply, divide, plot points, absolute value, I to a power. There are a lot of other side things that we need to be able to know so that we can really be successful to solve quadratics. Hey, it's a long one, but thanks for your time and see you next time.